everybody. Thank you for coming this early on the last day of the conference to my talk on designing commands for the PowerShell pipeline. Before I get started on the details, thank you very much to our sponsors for making this entire conference possible. Nothing here would happen without them. Their support, it's great there. Also, a big shout out to the invisible heroes of this conference, the tech team behind there, that actually make it possible that all the sound, video, and everything always works so flawlessly that you never even had to think about it. Thank you. So, before I delve into the details, the pipeline. The PowerShell pipeline is one of the absolute keystone features of PowerShell. If we didn't have the pipeline, let's be honest, we could be writing Python. It's a great feature. It is incredibly powerful, and we use it every single day when we open the PowerShell console. However, in many cases, when I see the script code we write, including my own, for some reason the pipeline is not as prevalent there. It's more like I feel like I have more control over my code when I'm writing classical C# style code with individual statements, try catch around everything in a lot more detail. So I decided, hey, what actually happens in the pipeline and what power do we get by breaking that habit and using the pipeline more properly, and most notably, design our code to make proper use of that power. Because if we're not writing the code to keep that in mind, well, then it's nice potential we've put on the shelf and never withdrew from there. So this is going to be very hands-on, as quite a few of my sessions. And now Q&A comes later. So mouse, where are you? There you are. So, pipeline. How the hell is this happening? Where is it happening? And why? First of all, implementing it for our own commands is quite simple. I've got a function. I want it to receive something from the pipeline, and PowerShell complains that this command does not expect anything from the pipeline, which is correct. We need to tell PowerShell what parameter should be receiving that. So, parameter attribute. This governs the behavior of a specific parameter that we're assigning it to. And there's this nice value from pipeline attribute. You can add the equals true. You no longer need to. I just learned it in PowerShell 2 where it was still mandatory. And you know how it is about habits that you don't break or that refuse to be broken. So, mouse, now is a very good time to go on strike. It worked. Great. I expected a string, I piped to it, and it worked. Is that everything? Not quite as such, because let's do, instead of a getItem, a getChildItem. And I'm assuming there are going to be a few more items in my Windows drive than just that one that I received right now. So, what magic is happening in the pipeline, actually? So let's do a second failure. This one is going to show something interesting. I'm trying to do get content on a text file, filter it out to only those greater than 25,000, and write that to the text file, the same text file, and it fails. The process cannot access the file because it is being used by another process. This error message is a lie. It is not being used by another process, it's being used by my process. With the error messages in PowerShell 7, this is really great. At the beginning, it shows us just what command was throwing the error. Set content was complaining, not get content. What's happening in the PowerShell pipeline is not that we first do command 1, then we do command 2, then we do command 3. In some way, all commands in the pipeline are active or enabled at the same time, whether they're actually processing at the same time or not. But they usually don't. So, I wrote some commands that will visualize us, paint on screen, the entire processing phase of the PowerShell pipeline. Need a bit more screen for that. So, what we have is the begin phase, the process phase, and the end phase. And what is happening with the processing is that first all commands in the pipeline will execute the begin phase. And only once that is done do we go back and start processing the first item in the process phase by going first through command 1, command 2, and command 3. Command 3 produces output. We didn't tell PowerShell what to do with that output. So what does PowerShell do? It sends it to out default, which is an automatic command. And out default will usually just print it on screen because, well, that's what we would expect when we run a command and don't store it anywhere. Then we are done with processing A. So we now go back and process the second object from the first command, for the first command, the second command, the third command. Then we do the same thing for this third object, Z, through all 3 stages. And only after we're done, there's no more input, we finally execute the end phase from the first command to the last command. And you can always see at the end that I always print like, what's the current value that we're processing? This is extremely important when we write our commands because during begin phase, we don't have anything. There's no value in there. When we design our commands and expect them to work in the pipeline, we cannot use any parameter in the begin phase that accepts input from the pipeline. It just might still be empty. If our commands, however, behave weird and only show us the last value, that's usually because we accidentally only executed the end block. When we have a function that if we have a function that only returns the last value, as it does here, that means, hey, this is happening in end, because in a function, if we don't tell it what phases to use, they all default to end. Fortunately, that is simple enough to fix. We can do a process around that. Note the error. Once we have one named phase in our implementation, we can no longer have code outside of phases. Just can't be done. We don't have to implement them all. We can just do the ones that we care about. And finally, this would work. We can update this a little bit just to show, hey, yeah, we did something, some preparation step. And okay, yeah, we can also demonstrate how much we have names here. But that should not be working. And fire. Mouse, come on, do your thing. We now have one discrepancy, however, and that is we can also explicitly bind the value, and it only supports one value if we bind it explicitly rather by pipeline. So what we would be doing is make an array out of it and in process a for each loop. And with that, we have the same behavior in both notations. So with this now, we can still execute this. However, we can now also that did not work out as expected. We can also do this and both work equally. So that's okay-ish. There's just one thing I'm annoyed with, that I want the name, not the full path. And I don't want to force the user to manually adjust how exactly they provide the object. It should be intuitively just working. Give me the name of the file, give me the name of the folder, not the full name or the full path. And this is where we have a second way of binding the whole thing. we can tell it to also do value from pipeline by property name. If we do that, and we now send it some values, PowerShell is first going to look, is there an object that is the object already of the expected type? If so, great, accept it. If it is not, does it have a property with the same name that has the correct type? If so, great, let's take that. Then it goes back, if neither is the case, can I convert the input object into the expected type, which in case of string has a high rate of success. Not always, but most of the time. In case you're wondering how, if you override it to string method, you can throw an exception then. That is going to ruin PowerShell's day. But with that, I can now take this. And since it is not already a string, it is now going to first look for a property named name. And we have that. And it's of the expected type. So, one last extension that we can do before I'm done with the basic implementation of how to actually accept from the pipeline. We can do multiple parameters that accept from the pipeline, including by property name. So, I'm going to make this a plain string. I'm going to ask for the attributes. And rather than doing this, I'm going to do a PS custom object, name equals name entry, and attributes equals attributes. I can also do a third one, input object, which is parameter value from pipeline equals true, and keep the whole object as well. This breaks down the entire for each loop processing at that point. That usually no longer makes sense. But with that, we can pick up multiple objects, and PowerShell is going to bind the same object multiple times if it can bind to multiple parameters that accept input from pipeline, or value from pipeline, or value from pipeline by property name. So, the input object column looks the same way because if you have a complex object in a property, it is going to call the toString method, and the toString method on a file or folder is its full path. The attributes also didn't work. Conversion failed. Yeah, whatever. I probably should not have done value from pipeline, because it managed to do because the attributes property is not a string, it's an enumeration. So it went back to input object processing, and that failed that. Going back. And now we should have the attributes there. So our command now accepts from the pipeline. We've had the phases. Here's a fun one that we often don't know. I can, for each parameter that accepts value from pipeline in some way, I can dynamically calculate the value by providing a script block. In that case, for each input object, it is going to execute that script block. In this case, that's obviously going to be a nonsense result, but it's going to work. Where it's more common is for something like this. Child item, pipe to rename item, new name, so this will allow me to rename all items based on the original input name. So, something to keep in mind. Again, when you're implementing this, also keep in mind if you want this capability for your parameters, it can't be a script block, and you can only use it during the process phase. That's the limitation that you're accepting in return for that capability. But I think this is a really neat one. So, going through the pipeline. Again, we are iterating through it and executing the phases. Begin, process, end. So there's one more fun thing that we usually do in functions when we want it to end early and we don't want to throw an exception, we use the return statement. Return ends a command. Sometimes we provide a value after it, which is not exactly what it's designed for. I'm going to be bashing about return for output in the next chapter. But it also ends the function, as we have learned. So we are going to be complaining about the number 2, which is my usual scapegoat if I need some dinner. And it's going to return things. So if I use the stop early parameter, I want it to end already during the begin phase. So didn't quite work out. Well, who would have thought? I'm going to ignore the stop early and just going to run get double with 3 numbers. So now there was 2 in there, which is evil, so we stopped. Working as designed, right? Working as designed. So, what return is doing? Return ends the current begin process or end execution phase. And since with a default function or a script where we don't specify the phases, we always execute an end, we only have one of those. And with that, return, in effect, ends our functions. However, if we implement the phases, we get multiple iterations. When we pipe to an object into a command, the process phase is being executed once per object, which is why when we have explicit, where we get exactly one process phase, the return again worked as expected. It ended everything. However, when we piped it in, it only ended the processing of the first value and then moved on to the second value. Because the second value, 3, started an entirely new process block. So if you want to end it, we either have to remember that we wanted to end a function, for example, set a variable, and in the next block, if variable, return, to return again and again until finally they give up. Or, what we should be more doing if there is absolutely no chance for success when we really want to kill everything, go with a terminating exception and swallow the red tags. Yeah. On the topic of red tags or making things break. I'm going to now show the pipeline processing again. This time, I'm going to throw a terminating exception in the begin block. Bit more space. Naturally, we won't be needing that for this one. As you can see from the processing, the first begin phase executed, the second begin phase executed, the second command's begin phase said, yeah, I'm throwing a terminating exception, and the entire pipeline stopped at that point. Taking this further, what happens when we have a terminating exception during the process stage? All begin executed, and then the second command running its first process phase killed everything, and we stopped there. And the same is true if we kill it at the last moment. The last end phase never got a chance. This is a great superpower for us if we do it right, and a great pain if we do it wrong. An example of why do we act this way? Let's say I'm trying to get all the mailbox statistics and then piping that into a table in a SQL database. And my friendly coworker decided now is a good time for a patch day. And is currently busy rebooting the server. Doesn't matter how many mailboxes I'm trying to write there, it's not going to work. So in this case, RedDB data table can kill the entire pipeline before I'm actually retrieving the first mailbox because I'm still during the begin phase and preventing everything. It also means it's great if you stop early, if you fail during begin and not during end, if nothing worked anyway. There is a second design consequence, and that one is really important. There is absolutely no guarantee for your command to complete without any fault of your own. You can do everything right, your command can be flawless, and you never get a chance to execute. Let's say I'm opening a connection during the begin phase and closing that connection during the end phase. If another command further down the pipeline kills us after establishing the connection, our end stage with cleaning up the connection does not execute. This is particularly important if you cache data in your module scope in some persistent context where the garbage collector does not clean up. Any variables that you declare within the function, no problem, the garbage collector picks those up. But, well, what if you don't get a cleanup? But this is not the best time to actually fail. The best time to fail is during parameter validation. In a pipeline, before the first begin phase ever execute, we do the parameter binding for the explicitly bound parameters. And if you have a validation error there, not a single begin phase executes. This is basically the key reason why I argue do your parameter validation during the param block and not during the begin phase. It is the earliest and cleanest way we can kill our code. And if we now write a script not using the pipeline, but intentionally breaking things down, we lose that capability. That a later command that cannot succeed the way we currently are or the way the environment is can no longer kill the entire pipeline because there is no pipeline. We just did a script from top to bottom. So, gonna need a bit more space here, because we're now coming to what I consider one of the greatest sins of PowerShell command design. This is something I beg all of you not to do to me anymore. I'm doing a command that's supposed to gather some statistics data for whatever I need to use the statistics for. I'm not implementing the details here, they don't matter. I get all my targets, I'm preparing a results variable. Then for each user, I'm building some data set after collecting more data and adding it to the results array. And finally, I return it. This is a pattern I see in most scripts I touch. And it is a horrible mistake. Please don't do this. Now, with PowerShell 7.5, you're no longer paying the exponential array addition tax. Adding arrays historically has the problem that they can't be resized. So PowerShell 4 creates a new array, one larger, copies everything over, which means that when we reach into hundreds of thousand objects, we reach into days of execution time just adding arrays. So don't do that. We have a better option. One thing many people don't know, the result of a for each loop, or a while loop, or a for loop can be assigned to a variable as well. You never needed to add to an array. This works flawlessly already as it is. But that's still a bad design. Don't do this. That's just saving you the array addition tax, but it doesn't save you the threads rough tax. So what you should have been doing is this. There is absolutely no good reason, no justifiable reason to store up the results. Just dump it into the output. Everything that you produce as output, which is not suppressed or stored in a variable, becomes the output of your function. There never was a reason for $results. Unless you later need to post-process and do more processing steps, different story. But just storing up the results so you can have the emotional comfort badge of doing a return on it is not just unnecessary, it's actually actively bad. You're probably wondering, why the hell is that bad, Fred? Well, let me do another pipeline processing show. And this time, I'm going to show you when the process block also ends. Not just when it starts, because the previous, hey, I'm processing A, I'm processing B, I always wrote it at the beginning. So we have the begin as normal. Then we have process start first, process start second, process start third. Then we return the output, then we finish up process third, then we finish up process second, and then we finish up process first. Whenever we produce output in a pipeline, our command is put on hold. And the next command in the pipeline gets to process it. This is pretty amazing because, for example, that means if you get content, a 2 terabytes text file, you first send one line over the pipeline, and only after it's done, the get content gets to continue and read the second line. That's part of what makes the PowerShell pipeline so incredibly memory saving. A quick hands-on demo with code that we actually can see to demonstrate that. But press space. I've got a command that is going to slowly return some numbers. And for each of them, it's going to write host, sending the number, produce the output, and then it's going to sleep for 1 second. So, and then I'm piping this to for each object. And as you can see, the code for each object is executing right away, and only then do we start sleeping. The pipeline can continue processing, and only then we continue. Which means if we use if we store up the results in a $result and then return them, this line is first going to store up every single summary data for every single user in memory. And only after we're done storing all of the 120,000 user objects in memory, do we write it to a CSV file. In the last notation, when we did a straight return, no storing up, just PS custom object without doing anything with it. We first send one object to export CSV. Then we continue generating the second object and write it to CSV. In other words, we only have a single PS custom object in memory, because it's immediately written away to CSV and forgotten. Then we can continue with the next one. It also means if I hit Ctrl+C, in my notation, my recommended notation, we have a few lines entries in CSV file already. If we stored up the results and only return at the end, well, it's going to be an empty file. So yeah, don't do that. One last quick demo. What happens when we return something in the end block? For this purpose, the second command is going to keep one object back. It receives object A, it is going to put A to side and not return anything. It receives object B, it is going to put B aside and return A. And the last object, object C, is going to be returned in the end phase. If we do that, you can see that first, the process phase of the third command did not execute at all. It was skipped. It didn't receive anything. It wasn't triggered. And in the final phase, in the end phase, the second command is going to return an object and triggered another process phase on the third command. There are some legitimate reasons to produce output in end phase. For example, sort object. Sort object can only know the correct order after it received all objects, and can only know it has received all objects if it's already the end phase. So the entire processing phase concept does not break if we return output in the wrong slot. So that's great. So Fred has told you, hey, it's great, we can do pipeline implementation, but what if I don't want to accept input from the pipeline? Do I have to care about the phase processing at all? Or can I just ignore it because, well, honestly, I don't care? Well, the memory advantage still retains, but there's also a second aspect. We've got a function that is returning letters without begin, process, end. And if I execute this, it's going to work as expected. We have the begin phase, of course, only from show pipeline, because getLetter does not implement this step. Produces an output, an A is processed, B is processed, C is processed, and finally we have the end phase in the show pipeline. But what happens if we do some input validation in getLetter after we got the param bindings done and it fails? We still execute the begin of the rest of the pipeline. Since we will decide, oh no, I'm not going to do begin process end, I don't care, that means our validation happens in the end block. And, well, that means all the others get their shot at establishing connections, trying to authenticate, leaving fingerprints all over the event log, your SOC team giving you calls, what the hell you're doing. Too bad. So even if you do not plan to accept from the pipeline, do begin and process if you have some validation to do after the begin block, after the parent block, because otherwise the rest of the pipeline is still going to do things. So, quick one. What happens if I pipe nothing to the pipeline? Empty array, nothing to see. We do get a begin and an end step, but we do not get a process step. If we accept input from the pipeline, we have to take into account that our process block is never going to run, but begin and end will. So declaring a variable first in the process block and later relying on it might hurt us. Fair warning. I've got a simple show execution command, which is going to show the phases being triggered. And, well, we get multiple process blocks for each item. If we bind explicitly, we get one process block. We always get a begin, we always get an end. If we now filter out the var object, with var object, so we actually accidentally filter out everything, show execution is going to show us begin and end still run. If, however, we do explicitly binding and it's still not going to produce any value, we get one process iteration. So keep that in mind when you're relying on where exactly do I declare variables, on what can I rely on having available. Depending on how it's executed, process might never execute, but the other phases. Parameter sets. Who in this room, raise of hand, who in this room has ever used parameter sets as in implementing it? Awesome. This makes me really love the next demo. If you have parameter sets with parameters that accept input from the pipeline, your parameter set is recalculated for every single object. So I did a little parameter thing, file info, directory info, value from pipeline accepted. And I'm just going to write what is the current parameter set. There we go. And we switched over. In the begin phase, we have all parameter sets as parameter set name now, because at that point, PowerShell can't determine what parameter set I'm supposed to be using. And then for each object, it picked the valid one based on input. So if you rely on parameter sets, keep that in mind. And again, the end block is going to remember the last option, which might not have been true for all executions. So, last one. I'll take another raise of hands. Who was in the proxy command session from Bruce Payette? Awesome. He talked about steppable pipelines. Steppable pipelines are absolutely super magic power, and I was glad he didn't spoil on the last point that I want to brag about or show off about. I've got a nice little command called export report, and all it's doing is it takes the input object and adds it to a CSV file. Currently, that's not using steppable pipeline. It's just plain, I'm going to add this now. So I need some objects to add, which is 1,150 objects. And I'm just going to use this command to write that to files.csv. You can see in my prompt at the beginning how long did the last execution take. And it's taking a little bit here. What's happening? With export CSV and append, we have the problem that for each object that I'm piping to it, it now opens the file. It scans the headers, it compares the object, does it have the correct properties, builds the new entry from that, appends it to the file, closes the file. Then it goes back and does it again and again and again. So we end up with 16.62 seconds execution time. If we had a straight export CSV instead, that would have been greater. I mean, still taking a bit of time, but no comparison. So we can use steppable pipelines to nest a pipeline into our pipeline implementing command. So in the begin block, I'm creating a variable command equals export CSV path dot get steppable pipeline. With that, now I have a portable pipeline I can continue executing whenever it's convenient for me. I still need to do a begin. This accepts multiple different parameters, but what we really need to give it is a Boolean true, which means, yes, you are going to receive input during the process phase. You are going to receive input by pipeline. And then I process the input object. And finally, we probably should also do the end, because otherwise the file is going to be kept open. But with this, I now have a single instance of export CSV for the lifetime of my command. So I'm saving a lot of processing time. I don't need to recalculate the headers every single time. And well, let's see how that works out for us. Well, I would say that was a performance gain. Piece of note, this is also a magic superpower when it comes to logging. Why? Your the file is kept open and logged for the time that the steppable pipeline exists. Classic situation, I'm using add content for logging. Add one new line to my log file. Antivirus. Hey, somebody changed that file. Maybe now it is a malware. Let's open it. I'm trying to send a second line. Oh, sorry, file isn't used, can't write to it. With steppable pipelines, you can keep your log file open. It also reduces the latency and flushing and overhead cost for each log entry, so your speed isn't blocked so long doing the logging. So it's quite useful for logging. When I publish this on GitHub, I will have an example logging setup using steppable pipelines as a reference. So you can look that up. It's going to be on my GitHub, and I'm of course also going to add this to the PSConfEU GitHub, so you can find the materials there. Well, is there even more? Well, it kind of depends if you have any questions. Anybody? Yes? Question, does my PS framework use steppable pipelines? Yes, it does. If you do a log file logging provider, it is going to very much use a steppable pipeline or two. Not seeing anybody else? In that case, thank you for joining me. You know where to find me. And have a good rest of the conference.